Okay, so today we're going to be focusing on parallel circuits. We're going to try different types of scenarios and solving them. So, of course, we got to start off with Ohm's law triangle. Now, things are a bit different in parallel circuits. So, first things first, we're going to solve for total resistance. Okay, first, in a parallel circuit, the voltage is constant and current is not. It changes throughout each resistor. And you can solve total resistance differently. This would be your equation, so forth. Now, given what we have, we solve, we get 1 over RT equals this turns out to be roughly 9.47 ohms. And the thing is, in a parallel circuit, this will always be less than any resistor in the circuit. The RT will always be less than. Okay, now that we have our total resistance, we can solve for the total current. It works the same like in a series circuit. Or no, it does not, but the Ohm's law applies the same way. So we have IT is equal to VT divided by resistance total. We know that our total voltage is 9. Turns out to be 9 volts. And we just solved for resistance, 9.57 ohms. This should give us around 0.95 amps, or could also be rewritten as milliamps, 950 milliamps. Now we want to find the current in each resistance. Okay. So once again, we know that current changes and voltage stays the same throughout. It's current, it's constant. So using this, we also use Ohm's law once again. Let's see, 20 ohms. Repeat for I2, voltage 2. Okay, now we're going to use Kirchhoff's law, and we're going to confirm since it's added up and it's dispersed, IT is equal to I1 plus I2 in this case. Now, let's see what we have. Now we confirmed with Kirchhoff's law, and we could see here that it's the same value as we did when we were using Ohm's law. And that's pretty much how you solve this. Here we have another resistor. In this case, we are missing the resistance of one resistor, and we do not know the I1, I2, and I3. Okay, of course. Let's start off with Ohm's law triangle. Okay, first things first, we can start identifying. We know that we have the total current, total voltage. So that means we could find total resistance by doing resist total is equal to plug in. This should give us around 0.62 ohms. So that is our RT. Now going back to our formulas to solve for resistance in parallel goes right. Now we plug in the given values that we have. Solve for R2, and you should get 1 ohm. If you want me to break it down, I can do this instead. And this just stays the same. So 1 ohm. That's our resistance. Now, to find our current, which with each resistor. I'm sorry, I meant R2 here. Okay. So we once again apply Ohm's law. We want to solve for I1 first. We take V1 and divide it by our first resistance. We know that voltage is constant in a parallel circuit, so this will be 9 volts no matter what. Our first resistor value was 10 ohms. This should give us around 0.9 amps. Now solving for I2. Same thing, voltage stays the same, 9 volts. With our given R2, we have 1 ohm. This just stays as 9 amps. I3, voltage 3, divided by the resistance 3, 9 volts, divided by 2. And this should give us 4.5 amps. Now, using Kirchhoff's law, we know that the sum of IT is equal to, IT is equal to the sum of all the individual currents. So we knew we were given 4.4 current amps at the beginning, and we use our solved values, 0.9 amps plus 9 amps plus 0.5 amps, and we get 14.4, and our check is right. Alright, here we have another parallel. Start off. Now let's start identifying. We have our total resistance, and we do not have anything else, but we do have I1, I2, and I3. Okay. First off, we know that Kirchhoff's rule includes that IT is equal to I1 plus I2 plus I3. So get the total current off the bat. And it's simply just 4 amps. Now, using Ohm's law, we know that Now, since we're going to solve for voltage total, since the one we're missing, we know that voltage total is equal to the current total times resistance total. And we have those values, right? So we have 4 amps times 40 ohms. It should give us 160 volts VT. Now, it's very important. Voltage is constant in parallel. So that means that VT is equal to V1 is equal to V2 equal to V3. That's what that means. So we can now solve for the missing resistor values because we also have the I1, I2, and I3 values. So in this case, we'll solve for R1 first, right? Just 1 second. Okay. R1 is equal to, again, this Ohm's law. Ohm's law will always apply. R1 is equal to V1 divided by I1. We know our value for V1, since it's constant, always going to be 160. Our I1 was identified as 1 amp. So our R1 resistance will be 160 ohms. Boom, simple as that. R2, same concept. Voltage stays the same. Instead, we have 2 amps. So we'll end up with 80 ohms. R3. Voltage stays the same. Current is also 1 amp. This one will also be 160 ohms. Now, if we want to check, we know that our RT is 40. So we can use with Kirchhoff's law once again. We could use the equation. And then if we check, yep, just had to make sure, and we will get the exact same values on each side. There goes our check. Correct. I always suggest identifying the given values and making sure to memorize or know the formulas you are going to use, and they will definitely help you. And that is all for this circuit here.